Moving on along to chapter 11. The goal of design patterns is to give you broad architectural templates for how you think about running into challenges in your application. So what we're going to start off with today is talking broadly about patterns, anti-patterns, and we'll discuss the principles of an acronym called SOLID, and we'll work through each of the letters over the next few segments. So design patterns, the goal is to promote reuse. And they are not just a software thing. They actually come from a book on architectural design patterns written in the 1970s. Although the ideas of design patterns predate the specific book, they've really existed throughout sort of millennia, right? Which is once you figure out how to solve a problem, you should reuse that solution. And so the book on architectural design patterns had a total of 253 sort of civil engineering patterns that covered everything from broad things like laying out a city to specifics such as how to design a roof cap on a building. And of course, the idea here is that there's no one right answer for what it means to lay out a city or what it means to lay out a building. But design patterns give us a starting point and a template for how we solve those problems. And of course, the useful thing here, right, is that when we do have design patterns and you go from one place to the next, as a consumer, you recognize those design patterns. So on a phone, right, pull to refresh is a design pattern for what it means for how you reload content in an app like Instagram or whatever it might be. Someone had to invent that design pattern. Someone had to invent roads and road signs in the way that we use them today. But as an engineer, when you're trying to solve a problem, you also have a pattern that you can reach for. And so the way to think about this is that they're a tool for organizing development ideas. Together, they make up what can be called a pattern language or a collection of patterns that help us solve similar problems. You may have heard the term design systems. Design systems typically refer to the UI elements, but they are also user interface patterns for how should things like buttons and modals and dialog boxes and all the good stuff that might exist in your app work. And so design patterns exist at just about every level. In the case of code, we're going to really be focusing on how do we make our code easy to adapt over time? How do we leverage working on teams? And so some of these design patterns as well will do things like help us minimize conflicts between different code bases or different features and so on. In software, there are broad levels of patterns. We can call them architectural or macro scale patterns. So think about early on in the book, the HTTP stack, the entire internet protocol stack, the layering model, all of these are sort of macro scale architectural patterns for how we build an app, right? We can build a SaaS app on top of HTTP because this is a design pattern that allows us flexibility. In computation, there are also particular patterns. The fast Fourier transform used in signal analysis and signal processing is useful for all sorts of types of projects. There are statistical patterns. There are ways of using linear algebra to solve problems. All of these sort of fall under smaller scale tools that might help us solve a particular task. And in software engineering, what we're going to do is look at a particular book called The Gang of Four, which is right up there in sort of the top list of software engineering books ever written. It's written by four folks, which talk about it provides three classes of design patterns: structural, creational, and behavioral. The Gang of Four design patterns, there's a list of 23 in the book. We're not going to go through all of them. That would be quite a lot. But the way that we should think about this is it's a sort of descriptive guide for how we should structure, in particular, object-oriented code, but not just object-oriented code. So how do classes communicate with each other? How do we think about classes that should be extended? How do we think about just tools for initializing objects and the various ways that we might do them? The four authors of the Gang of Four have their tools in all sorts, have their hands in all sorts of tools. Some of them went on to build at Microsoft the basis of the editor that became VS Code. They are responsible for creating things like the JUnit testing framework, which influenced tools like RSpec. So these patterns show up in many different ways. What in particular is a pattern? A pattern is not an implementation. So it's not a particular algorithm. It's not an individual class. An individual class can implement or use one or more design patterns, but patterns themselves are distinct from the implementation. They're also then, of course, distinct from any particular language, though some patterns show up more in other languages. So some people refer to these lists of 23 as sort of the pattern zoo or the grouping of patterns. So they start off with things for creating objects, factories, abstract factories, builders, prototypes, the singleton or null object pattern. All of these are how do we think about creating an object or a class that might interact with other things. Behavioral patterns deal with how we adapt a class's behavior over time, or how we adapt it from one generic circumstance to more specific ones. So we have the adapter, composite, proxy patterns, bridge, flyweight, facade, and decorator. Again, we're not going to go through all of these, and there's no point in memorizing the list of 23, how objects interact with each other. And then we have behavioral patterns. Behavioral patterns are the tools that allow us to modify the behavior of a class for a more specific circumstance without necessarily rebuilding the class as a whole. So observer, the mediator, the chain of responsibility, the command pattern, the interpreter pattern, iterator patterns, memoization, the state strategy template, and visitor patterns. If you've done Python right, you might recognize the iterator pattern from Python, which is to say, for item in range. Ruby's enumerable class works basically the same way. We'll talk about things like most of the ones in bold, but the idea here is that these patterns help us adapt the behavior of a class over time. The boundaries between each of the three categories can be a little bit fuzzy, but the goal is to say that these will help us solve a particular problem. Importantly, I would say the awareness of design patterns is useful because if you encounter a tricky situation, it's not necessarily helpful to say, how does the template pattern help me solve this? But to say, is there a potential design pattern that helps me solve this? And then go look up what that particular pattern is. So the goal with sort of thinking about these as meta patterns is we want to separate out stuff that changes from stuff that stays the same. When I say stuff, I mean both the implementation of our class, but also the ways and responsibilities that that class has. And we'll talk about, particular examples in a bit. But really just to think about is as an app's lifetime sort of grows, we'll have guaranteed rules, perhaps, or abilities of a class that won't change, and then we'll have things that need to be extended. So what we're really thinking about is the program to an interface, not its implementation. So these patterns work across Ruby and other languages. And the goal here might seem a little bit counterintuitive, given that we're talking about object-oriented design patterns, but we're going to prefer composition and delegation over inheritance. If you have worked in an object-oriented language like Ruby, or especially ones like Java and C++, you're aware that the inheritance structures can get really complicated. And so our goal is to simplify a lot of that complexity by not overusing object-oriented programming. Inheritance is still obviously very useful, but to delegate certain behaviors and compose smaller classes to solve the tasks that we need, rather than ending up with a ridiculously complicated class hierarchy. Within any sort of design pattern, there are anti-patterns. There are ways to think about code that looks like it should probably follow some design pattern, but doesn't, is an anti-pattern. And how you spot this, we'll talk about. But things that get close but not quite, or stuff that is needlessly complicated, will sort of hopefully stand out to you over time. Often anti-patterns are an accumulation of technical debt. Over time, when you refactor a class, you might refactor it in a way in which you sort of get the feature out the door, but don't necessarily think about the structure of the code. That tends to be the type of technical debt which design patterns can help you reduce. The way to think about this in practical terms of working on a code base is if it gets harder and harder to do the right thing over time, whether that's you have to make more hacks, whether you're copying code and your code is less dry, these are symptoms that perhaps there is a design pattern that could help you out that's not currently being implemented. And you can see this sort of from needless repetition. The other anti-pattern is sometimes harder to spot, but needless complexity coming from generality or overgeneralization. When you build an app, especially if you're building a tool like a library that's going to be consumed by other programmers, it's very tempting to build things such that they handle every possible case. But it turns out that a lot of times you don't need every possible case, and handling the general case in certain ways can lead to a lot of complexity. And so be wary of those kinds of things when you're working on a class and you see that something is complex because it's handling way more responsibility perhaps than it should. Of the design patterns, there's a set of object-oriented principles that we're going to talk about. The acronym is SOLID, and we'll go through each of these individually and look at examples. But we have the single responsibility principle, the open-close principle, the Liskov substitution principle, injection of dependencies, which was traditionally sort of the interface segregation principle, but injection of dependencies applies a little bit more in Ruby or in SAS apps, and the Demeter principle. And each of these are going to be tools to help us spot challenges in class design as our classes grow and get adapted over time. How do you think about design patterns? Well, we haven't yet covered chapter 9, but we're going to start, I think the big picture here of chapter 11 is perhaps easier to start with than chapter 9, but chapter 9 is about refactoring code and tools for dealing with legacy code. Without going through every single line of this table, because we'll come back to it, the goal of design patterns is really a high-level tool for our application. How do we think about sort of design smells in our app that apply to not just one class, but multiple classes? The tools in chapter 9 that we'll talk about are really about individual code level refactoring, particular things that help us with a method, metrics, and so on there. Some of the metrics change. So today we'll talk about LCOM. In chapter 9, we'll talk about computational complexity or cyclomatic complexity. The tools, the point, though, is that they have similar purposes. You apply them in different ways. So today we're going to be looking not at one class, but how classes interact with each other. So we're going to look at solid principles, and we'll start with those. We won't get through all of them today. A non-goal is definitely remembering all of the syntax, memorizing all of the design patterns. You should not try to memorize the design patterns. There is a helpful thing of sort of just being aware that some of these things exist in the world, in that, once you know about a design pattern, you now know to go look for it. And when you encounter challenges in your code, it is helpful to be able to refer to them in that way. And the goal, I would say, with Solid, when we go through each one, is to get the big idea and then be on the lookout for the implementation of that pattern. And along the way, we'll use tools to help us with that.